right, we're going to be finishing out the notes on pages 4 and 5 in your notebook. So the first one here says that we're going to name a regular polygon that has an exterior angle measuring 24 degrees. So remember, the exterior angle is equal to 360 divided by n. Miss Bass went through that on her video. That is at the bottom of the sum of the interior angles on our foldable cards. So when we substitute in here, we get 24 is equal to 360 divided by n. And if we divide, multiply, cross multiply and divide, that'll give us 15. So that's a 15 gone. Next one here, name the regular polygon that has an interior angle measuring 135 degrees. So the interior angle is equal to 180 times n minus 2 divided by n. So we're going to put in 135 and we're going to multiply there. That's going to give us 135n is equal to 180n minus 360 when we distribute. And we're going to solve that to get n equals 8, which is an octagon. Letter C, the sum of the measures of the interior angles, I highlighted in yellow and wrote that in yellow, is our equal sign. 3 times the sum of the measures of the exterior angles is that right there. When we solve that, we get n equals 8, which is an octagon. All right, over here we need to find the measures of A and B. Lots of places to start here. You can see I went through and put my 90 degrees in there. This triangle here is an equilateral, so then all of these must be 60. If we look at this 1, 2, 3, 4, 5 sides, each one of those must be 108. Once I get this, I know that 360 minus 60 minus 90 minus 108 is 162, and that gives me that angle there. If I take 360 and subtract 90 and 108, I will get 162. And then since this is an isosceles triangle, I know that this angle is already 162. If I take 118, I have 18, or 180 minus 162, I have 18 left. And so 9 would be here and 9 would be here, and that angle is 9 degrees. All right, let me kind of move this down a little bit here. Maybe, there we go. All right, so first one says to find the exact area of the triangle. So this was my thought process. I said, well, if I look at this and I kind of take the sides here, I can make this into a rectangle, okay? And so what I did was say, well, this is 10. From this point to this point is a 2. From here to here is a 4. Up to there is an 8. This is a 2. And then this is a 6. This is a 2 and a 4 down here, so that makes that a 6. And if I want the area that I kind of highlighted in yellow, you can see there are 1, 2, 3 triangles. So what I'm going to do is take the area of the entire rectangle, okay, which I did over here, just 6 times 10, that gives me 60. And then I'm going to find out the area of each one of these smaller rectangles. So looking at number 1, this is 1/2 of 2 times 10, and that's how I got the 10. Looking at number 2, this is 1/2 of 4 times 8, which is how I got the 16. Looking at number 3, this is 1/2 of 2 times 6, and I got 6. So I took that 60, that was the area of the whole rectangle, and I subtracted out area of triangle 1, area of triangle 2, area of triangle 3, and that would leave me with 28 units, and that should be units squared, and that would be the area of this triangle here. Okay. Looking at number 2, we want to find the exact area here. Well, if this was 24, I could take and draw in this altitude, making this 12 and 12. And then I could look at this and say that if this is my right angle here, this is my hypotenuse, I can do Pythagorean Theorem and say that the h, which I didn't know, squared plus the 12 squared, 144, is equal to 8 times the square root of 3 squared, which is 64 times 3, which is 192. And subtract the 144 from 192, I get 48, which is 16 times 4, or 4 times the square root of 3. So that's how I figure out the height. Once I have the height, I can say that this is 1/2 the base, which is 24, times the height, which is 4.4 times the square root of 3. And so that is going to give me 48 times the square root of 3 centimeters squared. All right, in the next one here, we can see this is 30, so I'm going to draw this in. This is going to be 15 and 15. And then I'm going to say 15 squared, which is 225, is going to be equal to h squared, or plus h squared is going to be equal to 17 squared, which is 289. Subtract 225 from 289 gives us 64. Square root both sides gives us the height of 8. And then to find our area, we're going to take half of 30 times 8, which is 120 centimeters squared. All right, let me go ahead and move this up. Okay, and if we're looking at the next one here, number 3, it says the exact area of an equilateral, so all of our sides are the same, with the side length of 4 times the square root of 5. So if I take and draw on this altitude here, if this was 4 times the square root of 5, and this was 4 times the square root of 5, this part here must be half of that, which is 2 times the square root of 5. So if I need to figure out this height here, I'm going to say that the height squared, I don't know what that is yet, plus 2 times the square root of 5 squared is equal to 4 times the square root of 5 squared. So you can see I end up with h squared plus 20 is equal to 80, and then h squared equals 60, which is going to give me 2 times the square root of 15 for the height. And so then our area is going to be equal to 1/2. The base, remember, would be 4 times the square root of 5, and the height is 2 times the square root of 15. And when we multiply and simplify, that is going to give us an area of 20 times the square root of 3 inches squared. All right, B, the next one here, we are looking for that the area, we have the height, and if we are looking, we need to find the other sides here. So if we have the height, and if we take and put this in as a 90 here, what we would have is a 30, 60, 90. And if we're given that this is 4 times the square root of 5, then to be able to figure out the short side, this is 4 times the square root of 15 over 3. That would be that part. That would also be this part. So when we go to figure out the area, we have to add these together to get the base. So 1/2 times the base, which is 8 times the square root of 15 over 3, times 4 times the square root of 5, is going to give us an area of 80 times the square root of 3 divided by 3. All right, and then looking at the last one here, we're given a right triangle. And so we are told that this is an altitude. And then we are asked to find AB, which is this. We are asked to find the area of the triangle, and then we are asked to find the measurement of the altitude. Okay, so the first part there I did in red, and I said, well, if this is a right triangle, then this AB squared plus the 68 squared is going to equal the 85 squared. And when we do the arithmetic there, then we can see that AB ends up to be 51 units. And then if we look at the triangle like this, this would be our height, this would be our base. So our area is going to be equal to 1/2 our height times our base, which gives us 1,734 units squared. Now that area is the same area, and now we know the base is 85, and if we want to figure out this height, the area, which we just found, is equal to 1/2 times the base, which is 85, times the height we don't know. And when we do the arithmetic in there, we're going to get 40.8 units.